Okay, guys, can you hear me?
Yep. Yes.
Yeah.
Okay, great. So last time, just a sec, just string controls. Okay, so very good morning, and we shall start with the week 2 session.
Hey, good morning. And we should start the
Hi, good morning. Yeah, I'll just put everyone on mute, and we shall start with the session. Okay. Okay. So last time, I think some of you didn't attend the last Sunday session. So we had delved into a little bit of matplotlib, that is for the plots that we are using in Python. Then we had gone into the basics of pandas, which is basically uh, the data structures that are being fed to the machine learning techniques in Python. So, and then we also entered into what is regression, what is classification, what is supervised learning, what is unsupervised learning, what are the, and then we also had seen some amount of linear regression. Now, since many of you didn't attend the last Sunday session, I'll give a recap of linear regression, and also it will be beneficial for people who had attended, because linear regression being the basics of machine learning, I think it needs to be crystal clear for everyone, because otherwise it will be very difficult for you to understand more complex models. Okay, so we'll have a recap of linear regression today, and also we'll start with statistics, which is the basic building block of machine learning. Okay, so let's start. Okay, so the basics as remains same. Okay, so I just wanted to let you guys know that just save the meeting, passwords and the link, so that you don't miss out on the content. Okay, so now, as I told you, what we will be doing today, and then we will also see some amount of bridge and lasso. What does this mean? Don't get bogged down by the terminologies. It's again a model. So we'll see why ridge and lasso exist, and what are decision trees. Okay. Now, statistics. I'll not go into definition of statistics. It's a Wikipedia. I mean, it's a basic Google definition of statistics. Don't go into that. Every machine learning model that we will see, or we are going to have in this world, is based on statistical learning. Okay, so statistics is basically your knowledge about the data. Okay, so you are collecting the data. There's some amount of science that goes into how you should collect the data. There's some amount of science how you should analyze the data, and then there's particularly there's some amount of science in how you want to predict your future. Okay, so everything that revolves around this science is called statistics. Okay, so basically, I think these are very basic definitions that we can see here. But though these are very basics, these still remain the most important, terms that are being used in statistics, and every model more or less revolves around all these things. Okay, so let's look at the mean. What is a mean? So mean is basically a mathematical average of the values that are existing in the data. For example, if you have so many numbers, there will be a particular mean. I mean, the center of the data. Okay, so for example, you just sum up or sum this all, and then you divide by the number of items in the data set. Will not go into the calculation, because I think that's pretty much simple, pretty easy calculation that we have to do. Okay, what is a median? Median is basically if you arrange your data in an ascending order, or let's say however you want to, but it should be ordered, right? It could be descending or it could be ascending. You have to arrange your data in a particular order, sorted array. Okay, and then the middle value. Okay, the middle value, if it is an even number, you get the middle value in points, so you take the greatest integer function, okay, and if it is a odd value, then you will obviously get a particular middle value. So it is always the middle value that we are taking in the data. Okay, so I think again a calculation of median is not particularly. I mean, it is not rocket science. It's very easy. So we'll not go into the calculation of this. What is mode? Mode is basically the number which is repeated the most often in the data. For example, if you have each of the numbers, you map the numbers to its particular frequency. So for example, 1 exists 1 time, 2 exists 2 times, 3 exists 3 times, 4 exists 2 times, 5 exists 1 time. What is the mode? Mode of the data is 3 because it exists 3 number of times. So the frequency of the number which has the highest frequency in the data. Okay, now a question for you guys. Uh, Okay, now before that, do you guys know anything about outliers? Give me a yes or no on your chat box. What are outliers? Can I get a yes or no on the chat box? Okay, Sharad has answered. Okay, person has answered. Okay, so let me tell about outliers. Okay, now let's take an example. So last time what we talked, I think you guys remember about the collection of data. For example, you are sitting we are sitting in a medical clinic in India, okay, and you are collecting the heights and weights of all the people that are visiting in your clinic, okay. Now you're in India. Suddenly, an Australian visits. Okay, you note down its height and weight, and then again you have Indian patients, right? And then suddenly an African visits. Okay, so you note down the height and weight, and again you have a flow of Indian patients. Now, when you plot the whole data, what you could have collected in all over your 2-3 days or whatever time frame you have collected the data for, you'll notice that 2-3 points are, I mean, do not lie in the general framework of the data frame. For example, Indians would be around, let's say, 5.5 to 6.1. Okay, some might be beyond that, but generally that is the structure, right? And their weight is also varies between 55, but not 55, around 60 to 75, 80, or 85. But you would see some Australian that has come in your data frame, come in your data. He might be 6'6" or 6'7". Okay, now for your data, this Australian is an outlier. Okay, he doesn't represent or he doesn't come from the same population that you're trying to look in your data or analyze in your data, right? That's a very basic definition. This outlier so I've already told you that there's an Australian coming in, so it's very easy to identify. But there's some many times that you would not know that who is this Australian, or in that matter of fact, what data is an outlier, right? You could have data for many things. It's just an example I gave of height and weight. So you'll have outliers of many types. So you would not be able to identify which are the outliers. So here comes the statistics. Okay, so we'll define how we'll get to that how you define outliers. Now, okay, this is a little tough question, but I'll be very happy if you could answer this. I've explained you mean and median, right? Now tell me which one of these parameters is more affected by outliers. I mean, will your mean change a lot with the help of outliers, or the median will change with the help of outliers? Or let's say, which is the parameter more robust to outliers? I mean, it does not change with outliers. Can I get answers on my chat screen? Okay, Sharad has said median will not change. That's the correct answer, and that's great, Sharad. So median is a statistical, what do you could say, parameter which is robust to outliers. This is a very important statistic question, a basic question that people would ask you. But this knowledge of a mean and median will help you a long way when you do modeling, right? So median, remember this: a median is robust to outliers, mean is not robust to outliers. Okay, so just remember this. And mode is good to know, good to have, but it's not very important most of the times. So we'll not go deep into the modes and all. Okay. So we have already said, I mean, no need to calculate all these things. These are very easy. Okay, now standard deviation. So standard deviation is the spread of the data. Uh, Obviously, when you're collecting data, you'll not expect everything to be same, right? Then it defeats the sole purpose of collecting data. So there will be variations, right? So when you are saying that there will be variations, what is the spread of the data? What variation you're talking about? Okay, just a second, just hold on. Yeah, it is important to know what spread you're talking about, right? Now, the spread, for example, it can be very high if your data is, for example, um, if your data, for example, if you're taking the population census, or you're, let's say, you're collecting the height and weight all over India, not in a single clinic, but you're collecting the height and weight all over India, right? So there will be a definite, a huge amount of spread, because North Indians, South Indians will have different metabolisms, different body structures, similar to East India and West India. So every Indian is will be different, right? So there will be huge spread in the data. So how do you measure the spread? Okay, so this is what we call variance, right? Variance is basically how your data is spread from the mean. Okay, so for example, this is your data. Okay, this is your data. You have a particular mean, right? And then when you have this mean, you check what is, how far is each of these data points from the mean. So 1 minus mean square plus 2 minus mean square plus 2 minus mean square plus 3 minus mean square. Why we are taking square? Because to, not consider the sign. I don't want to consider the sign. If I consider the sign, then it will be zero, right? Because if it is equally distributed, I would say all the positives and all the negatives cancel out. But that is not what I want to tell you. I want to tell you the spread of the data. So that's why we are taking a square, adding them up, and then taking a mean of that, and then we are taking the root of that. So root means square. Okay, similar, you'll come to this concept when we are doing linear regression, what is root mean square. But it is, variance is only till the square part, then you go to standard deviation, you take a root of that. Okay, so again I'll tell you how your data is far from the mean. 1 minus mean plus square plus 2 minus mean square. You add all the differences, the square of the differences, then take a mean. So a number of items: 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 items. So divide that sum by 9. Whatever you get, that is the variance. And if you take the square root of that, you get to a standard deviation. Okay. So any questions till now? Yes or no on the chat screen? Okay. Okay. So I think we are good. So I already told you the standard deviation. Now, okay, I'll not answer this. I need the answers from you guys. For example, if you have this data, what happens to the mean and standard deviation when we add 2? Add 2 as in just add 2 in the data, not 2 in each of the data elements. Just add 2 in the data. Just tell me whether it increases or decreases. Both will change. Sure, that's great. So you can have an approximate mean identification, right? So for example, you are saying that 3 are, when you actually calculate, mean will decrease. Sharad, that's correct. Mean will decrease. What about the spread? Any answers about this? Okay, let's not get into that right now. Let's answer this one. What happens to mean and standard deviation when we multiply by 2? Each of the elements are multiplied by 2. What happens to the mean? So for example, if you have your mean will increase, so mean will actually double up. So if you multiply that each of the data elements by 2, mean will actually double. Exactly. Yeah, correct, Sunny. So mean will increase by 2. What happens to the standard deviation? Standard deviation will not change. Okay, one answer I got that. So can you okay, I'll not go into explanation. For example, if you go and change the mean, okay, so everything doubles up, right? Now what I told about standard deviation is the difference between this element and the mean. Okay, so for example, right now one, let's assume the mean is 3.5. Okay, I have to calculate. Let's calculate 9, 13, 16, 19, 22, 24, 26, 27 divided by 9. Mean is 3. Okay, so the mean is 3. Now if you multiply this, the whole data mean will be 6. Okay, now so this will be 2, 4, 4, 6, 6, 6. Okay, 8, 8, 10. Now if you take the standard deviation, this will be 2 minus 6 square plus 2 minus 6 square plus 2 minus 6 square. Okay, you add up. You can actually take 2 out of the proportion, right? So if you take 2 out, so it will be again 1 minus 3 square plus 1 minus 3 square plus 1 minus, so 2 will come out. If you take it from the square, inside the square, then 4 will come out. And then if you add them up and then you take a root of it, then 2 will appear, right? So your standard deviation will actually increase by 2. Did everyone understand this, or I'll explain mathematically? Okay, Sharad has understood. That's great. So basically everything remains same, but each of the brackets of those squares will have 2 inside the square. When you take it out of the square, it will be 4, right? And then 4 will be common from each of the brackets. And then when you do a standard deviation, it will be under root of 4. That will be again 2. Okay. So this is very important. And divide by 2 is similar. If you divide by 2, the same thing happens. Now this is very important. What happens to mean and standard deviation when we do the following transformation? Okay, so if you do a transformation, I mean each of the data is multiplied by 3 and changed by 2. What will happen to the standard deviation and mean? Answers? Both will increase. Sharad has correctly answered, but how much? Increase by how much? Okay. Okay. So I think none of you answered this correctly. When standard deviation will be 3 times. That's right, Sharad. But okay, now let me explain this. When you multiply this, each of these 3 we have already seen, right? If you multiply x by 3, then your standard deviation and mean both change. It's the same thing as we did as when we did for the previous example, when we multiplied by 2. 2 and 3 don't make any difference. So when you multiply by 3, as your mean and standard deviation will change. However, when you do a shift, okay, this is called a shift. Okay, when you do a linear shift, or you add or divide or add or subtract 2, every element will change, right? So your mean will increase. Okay, so every data is shifted by 2, So your mean will change. However, your standard deviation will not change, because in standard deviation we are taking the difference, right? So this has also increased by 2, and the mean has also increased by some portion. Okay, but we are taking the difference, right? So that's why it will mean is not mean will change because of the shift, but standard deviation, since we are taking the difference, always remember standard deviation is the difference between the elements, right? So if one element shifts, we are shifting all the elements, right? So all elements shift by +2, so the spread of the data doesn't change, the data just gets shifted. Okay, all the units shift by +2, but your data as such remains constant. So your spread will be same, but your mean will change accordingly. Is this clear? I was just talking about the +2. 3 times both mean and standard deviation will change by 3 times. Okay, so I think everyone is clear on this. That's great. So this is very important, this concept, how your linear shifts happen. Okay, so just remember, if you add and subtract, standard deviation does not change. However, standard deviation will change if you multiply or divide your data. Okay. Now, each of the diagrams that you see here are called histograms. Okay, so basically, what does this mean is, this is the frequency. Frequency, as I've told, how many times a particular number occurs, right? But when you're plotting a histogram, you don't actually plot single numbers, you plot into buckets. Okay, so if you see here, sorry, if you see here, it's a bucket of 40 to 50. Okay, so whatever number falls between 40 to 50, 50 excluded, because 50 will get into the next bucket. So 40 to 50, whatever number falls into that bucket, how many numbers actually fall into that bucket? Okay, so almost four numbers fall into that bucket. Similarly, like this. So this is basically a histogram with 10, where the unit of bucket is 10, as 10. So similarly, you can plot many histograms, and the histograms can look, can take any shape, right? So this is also an histogram. But if the shape is like this, okay, this is called a normal distribution. Okay? It's also called a bell curve. It's also called a Gaussian curve. Okay. For now, we'll call this as a normal distribution. What is the particular property of this normal distribution? This is the most important property of a normal distribution. Your mean, your median, your mode is equal. That's why it is called a symmetrical distribution. Okay. So data is equally spread from the mean. So for example, if your mean is, let's say here it is 150, I think, or 155, I guess 155 is your mean here. Mean is 155. If you arrange the data, 155 is the middle value, and if you have most number of 155 in this data, so that's why its frequency is the highest. It is the middle value and it is the mean. Okay. So any questions till now? Yes or no? Okay. So I think it's clear to everyone. That's great. Um, so as I told you, if your median, the definition of median is this. Okay, Sunil has a question. Could you please go on that graph? Okay, yes, I went here. Let me tell me what is the question here. Sunil, what is the question here? Okay, I'll unmute you. Yes, Sunil, tell.
Yeah, could you hear me?
Yeah, I can hear you.
Okay, so in this bell curve graph, basically,
Yeah.
just I want to go. This first one is 100 and then unit is 5. What does this mean? There is one element of 5. Am I right?
No, I didn't understand which one you're talking about. The
Okay.
right,
Where last one,
the
basically,
bell curve,
yellow
right?
one.
Yeah, yeah. Okay. Now, okay. So
So
you're talking about what this,
on the first one,
what
no,
this.
no, I'll come later on bell graph.
Okay.
Yeah, just I want to understand this chart, histogram basically. So on 100 to 110, frequency is 5, or there are 5 units. Am I right?
Yeah. So for example, you have five numbers like 104 or 105, 103, 102, something which falls between 100 and 110.
Okay.
Okay.
No,
Then,
just I'm thinking if I will average out of these all numbers, will it come 150 or not?
yeah, yeah, yeah.
That's what I'm
It will
thinking.
come. Definitely, it will come, right? It will come, I think, 155. That is the center of the bin you have to take. The center of the bin is 140, 150, 160. So 155 is the center. So it will come. Definitely, it will come. It is a basically a weighted average. So, but see, here you're not getting the exact numbers, right? These are bins. You have to keep that in mind. You're not telling me whether it is a 102, 103, or 104. I've created bins of 100, 210, and I said that there are five numbers. But which are those five numbers? You don't know, right? It could be 18, 108, it could be 104, it could be 103. You don't know exactly which number you're talking about. So you cannot calculate the mean directly from here. I mean, just seeing this. But if you can see the mean is set,
So,
so it is 155. But you cannot say that I am taking 100 5 times, 100 10, 10 times. Not that. It's not like that. Okay.
okay, got it. Thank you.
Okay. No problem. Okay. So I think we are good to go. So I think we have understood this already. Okay. Now note this down. Very important. Normal distribution is the most important distribution in statistics. Why it is very important? Because everything that happens, um, for example, in your nature, 80% of it will follow normal distribution. So basically, every nature will follow symmetry. That is the concept. So for example, if you drop sand from your hand, it will always go form a normal distribution. I mean, it will be in 3D, but if you can picture that, it will be a normal distribution. It will always be a kind of a Gaussian bell curve. Okay. If you take heights of people, it will be some people will be tall, some people will be short, but average it will be symmetrical about the mean. If you take the marks of the student, it is normal distribution. If you guys have done any time done performance ratings, every company almost follows normal distribution bell curve. And that is a bell curve. So top 5% people get I mean excellent, the medium 95% people, I mean 90% people get the average rating, and the below 5% people are average performance, below average performance. So everything in nature will follow a normal distribution. Not everything. Don't jot down that everything, but most of the things follow normal distribution. Okay. So now that's why normal distribution is very important, and that's why we'll go into little depth in this. Okay. So for example, your normal distribution. So this is your smoothened out histogram. So everything is a histogram. You just have smoothened it out with the curve to represent. Now, what we talked about standard deviation is the spread, right? So one spread from the mean and one spread from the mean towards the right. So one spread here and one spread here. Total this area will cover 68% of the data points. This is a unique property of normal distribution. Every distribution will not follow this property. Okay, so let's say a uniform distribution will not follow. I'll not go into other distributions right now, but just to make you understand, it is a unique property of normal distribution. One standard deviation will, from the left of the mean and to the right of the mean, will follow 68 fall. I mean, captured 68% of your data. 2 standard deviation from your mean to the left and 2 to the right will capture 95%. Similarly, 3 standard deviation from the mean towards the left and towards the right will capture 99.7%. Okay, so it's very good if you can remember these things, because this will be very important. But no harms if you even don't remember, but it is good to have this. So, for example, if I say 95% people, for example, let's say the average score in a maths test was 8, let's say 60. Okay, so this average mean is 60. The spread or the standard deviation of the data of the marks of the students was, let's say, 2. Not 2, 2 is very late, 5, let's say 5. Okay, so 60 minus 2 into 5, that is 50, and 60 plus 2 into 5, that is 70. Between 50 and 70, 95% of the students are there. So, for example, if it is 40 students, then 38 students are inside this particular part. Okay, the rest one student is above 70, and the rest one student is rest two students, one of them is above 70 and one of them is below 50. Okay, so this is the meaning of this. Similarly, at 99.7%, it means literally, in if you take in 40, that will be, let's say, 0.3% of 40, that will be zero point 0.3, that is 1.2, not 1.2, yeah, 1.2. Not sorry, not even 1.2, 0.12. So 0.12 doesn't exist, right? So that it means you have almost captured all students in this 99.7%. Okay. Any questions on this? I think you can ask me on this. This is a little new to you guys. Any questions on this? Leave me a chat on your chat box. I'll unmute you if required. Okay. So I think Vasant, are you clear on this? Clear. Okay, great. Okay, now this is a very important concept. So, when we are talking about a curve, right? When we are talking about this curve will have an equation, right? So I am not just blindly plotting a curve. Okay, this curve will have an equation that is called the PDF, or the probability density function. What signifies is, if you put a point, if you, let's say, put a point, let's say what we had in marks, like let's say 65. Okay, so 65, if you put, it will tell you. In a PDF, understand this. This is very important. A probability density function. Just go by this word. Okay, so what is a probability density function? It is basically the probabilities of the let's say range of data what we are talking. So, for example, if you want to talk about what is the probability that in a class of 40 students there will be, what is the probability of getting a student, if I pick a random student from a class of 40 students, what will be the probability that his marks lies between 50 to 60, or let's say 50 to 70? That is 68%, right? 0.68 is the probability. What is the probability that if I pick a particular student out of a class of 40 students, what will be the probability that his marks are between, so it was so this was, sorry, this was 60, so 2 into 5 10, and 2 into 5, so 50 to 70, 95.95%, 0.95 is the probability, or 95% is the probability that if I pick a student from a class of 40 students, his marks will lie between 50 to 70. Okay, so this is how you define a probability. So Now I've already told you that this is 95%. What if I want to check something between, let's say this was 60, so this is 65, this is 70. Yeah, how are you calculating this probability? Right. So Sunil has a very valid question. That's what we are trying to tell you here, that this particular equation has a this particular graph has an equation related to it. Okay, now that equation is very complex. That equation is very complex, and people don't want to remember that. So it is something like e to the power x minus mu, x minus mean, basically divided by the standard deviation whole square. So it's a very complex equation. People don't want to remember that. So what people have come up with is called a Z table or a Z score. So this Z score, what it defines is, I want to, so your data will be, I mean, it can be anything, right? Its mean can be 60, for example, its mean can be 120 if your total marks are of 200. So its mean can be anything, right? So what it defines is, I want to know what is the Z score if you're given a data. For example, how far your data point is away from your mean, how many times it is away from your mean based on your standard deviation. Okay, so for example, understand this very carefully. Okay, for example, if I take this example what we took, right? So we had 60 here, we had 65 here, we had 70 here. Okay, so x is 70. For example, I want to take someone who, okay, now this Z score will tell you the point. For example, if I am taking this point, what is the probability of having someone who has scored this much marks? What is the probability of having someone less than him? Okay, so just understand this very carefully. Okay, so for example, this whole curve is 100%. Okay, so there is 2.5% remaining here and 2.5% remaining here. So why could I tell it is 2.5 2.5? Because normal distribution is symmetric. So 5% is remaining out of 100%. Equally distributed amongst this is 2.5, 2.5. Okay, so if I take this point, okay, let me take out my drawing tool. If I take, if I take this point, okay, and I consider the whole area, this will be how much? 97.5%. Okay, because 95% plus 2.5%. Now, if I take a point from here, so I tell that what is the probability of, so what is the probability of someone, this is x, less than 70? What is the probability of a person scoring less than 70 in this particular test? So that is 97.5% is the probability. What is the probability of a person getting more than more than 70 here? That is 2.5%. Okay, let me erase this. Wait, how can I erase this? Erase all. So is this clear till now? I'll go into the Z score after this. Okay, I think it's clear. So now your Z score is basically, all these areas are known when it is one standard deviation and two standard deviation. But there will be instances when you are 1.5 standard deviation or 2.5 or 2.6. Okay, so for example, let's take this example. So your x minus mu divided by sigma. Here when I had put 70 and this was 60 and this was 5, 70 minus 60 that is 10 divided by sigma, that is 2. Sorry, sigma was 5, so I got 2. Okay, so I got this one. What about if I get 75? I want to understand what is the probability of a student getting 75. Okay, so 75 minus 60, sorry, divided by 5, so that is how much? So 75 minus 60, 15, divided by 5, 3, so 3 standard deviation. Okay, so I'll get my point here. So what is the probability of a person getting less than 75 in this test? Okay, so this area. Now this has all come to exactly 3 we already know here. What if this is 76? Okay, so this will be 3.2. Okay, Sunil has told me to take an example and draw. So Sunil, okay, let's understand this. Okay, Sunil, it's not clear to you. Okay, no problem. We'll help you here. So this is 60. This is, let's say, okay. I mean, it's very difficult to draw with a mouse. Uh, okay, okay. Let's understand from this. It's very difficult to draw with the mouse here. Okay, so just bear with me on this. So this is 70. Okay, now your this is a distribution. Okay, so these are all are distribution, so you need to understand the probability. So what, so for example, you are a class teacher, you have conducted this test, and some person, your principal, comes and asks you, I want to understand how your class has performed. Tell me the percent number of students, or what is the percentage of students that have scored below 76. What you'll do, you'll go and calculate from your data, right? Go into an Excel sheet, do a conditional formatting or do a filter, okay, and you calculate the number of students that have scored below the 76. Okay, that's how you tell your principal. Now if you're smart, you'll not do that. You know that your mean was this, your class is almost normally distributed. You quickly say him, okay, I know this answer. So what you're asking, you're asking him 76, right? So 76 minus 60 divided by my standard. You have already pre-calculated your standard deviation. So you know that what he's asking, someone who has scored less than a 3.2 standard deviations away from the mean. So this point, what is the number of students who have scored less than this point? Okay, so these all are marks, right? These all are marks. So this is 60, this is 65, this is 70, this is 75. So you have scaled it, right? You have scaled it to a normal -1, -3, -2. You have scaled it. How you have scaled it? You have scaled it by this Z score. Wait. You have scaled it with this Z score, right? So you're very smart. You tell that I know this point. You're talking about someone who has scored less than 3.2 standard deviations from here. So that answer I know. Okay. Now here,
So, one second. Can you explain? You did subtracted 60 and then divided by 5. What is the reason you did that number?
so
76 is the mark.
76
If
is
you want
the
to
mark.
choose, right?
60,
Where is the 60?
60 is the
And
mean. Okay, and standard deviation. So you want to understand how many standard deviations away is your data point. Okay, so
Mhm.
x minus mu, that is the difference, that is the gap, divided by standard deviation. How many standard deviations your data point in consideration is away from the mean?
So you already know that this standard deviation is 5.
Yeah, you have calculated. So
Why are you dividing by 5?
so when you have calculated the marks of the students, you have done a mean, you have done a standard deviation. So you know the standard deviation, you have the marks of the students, right? So you know the standard deviation, you know the mean. Now there's something that I'm trying to say here. For example, when someone asks you about 70, right, you know that 70 is two standard deviations away from the mean, of two standard deviations away from the mean. But if someone asks you about 80, you don't know that answer, because here you only know 68%, 95%, and 99.7%, right? So if someone asks about 60, 70, or 80, you can tell him about that. But if someone asks you about 85 or 76 or let's say 78, how will you tell the answer? Are you understanding this? This is a probability distribution. Any number can fall between 0 to 100, right? So you know the answers for particular standard deviations. But what if someone asks for 77? You need to go into this graph. You need to see how much far is 77 from the mean in terms of how many standard deviations. So 77 minus 60 divided by 5, which you had calculated from the data. The mean also you had calculated from the data. So 17 divided by 5, that is 3.4. It means the data point that your principal is asking is 3.4 standard deviations away from the mean. Now, there's something called a Z table. Okay, so you go into that Z table and you check that what is the percentage of the people who are below 3.4 standard deviations below in a normal distribution. This will be fixed every time. It will be fixed whether you're talking about 1000, whether you're talking about a test conducted out of 1000 marks, whether you're talking about height, whether you're talking about number of accidents. Everything which follows a normal distribution will follow the Z score table. Okay, what you're trying to do is you're trying to scale it, or you're trying to make it unitless, right? So whether you're dealing with the data of height, or you're dealing with data of marks, or you're dealing with the data of number of accidents, it doesn't matter what your Z score is telling. Just tell me how far is your data point from mean divided by the standard deviation. If you tell me this, I can go into the Z table and tell you what will be the percentage of people below that number. That number can be age, can be height, can be weight, can be marks, can be anything. This is a standard formula. Okay, so every normal distribution can be plotted with the Z score, and this Z score can be checked in a Z score table. Is this clear, or should I repeat it again? Any particular questions? This is very important for you to understand. I'll unmute everyone here, and everyone can ask their questions. I've unmuted everyone here.
Hey, Subodhi.
Yeah.
Hello.
Yeah.
Basically, this is one and important and basic concept, basically, which is not clear to me still.
Okay.
So, could we take one example, numeric example, number you are giving, exam result number? So, 1, 10, 20, 30. Could you take this type of number, draw the graph, calculate the mean, SD, and then after that we will calculate Z score.
Okay. So I think that will be
because whatever example we have taken, that is 1, 2, 2, 3, 3, 5, 5 something, and we are drawing graph based on the marks of 100, 1 to 100, and so that is not actually. I am not able to map everything.
Okay. I think it's a long exercise that you're asking me to do, and I think people will who have understood it, they will like to go ahead. But to clarify your doubt, I will again reiterate. So forget this 1, 2, 3, 4, 5. You start from the starting. I'll take again, because to complete do all those exercises, it will take a lot of time to calculate mean, plot, and all. So I'll just explain you, and let's understand this. If it is not clear still, then we'll again see that in the end of the session. Okay.
Otherwise, Subodhi, one thing, if other persons are clear, then I'll take as a homework for today. I'll try to take this example over the internet, and I'll go.
I'll explain you once more. I think it will benefit everyone. So just understand this. Forget 1, 2, 3, 4, 5. That was an example. I'll again take this marks example, because it will be easy for you to calculate, or easy for you to understand. Imagine you have conducted a maths test, okay, out of let's say 100 marks. Okay. Now you have 40 students in your class. You have conducted a maths test. There will be students who have scored any marks, right? There will be someone who has scored 40, some 50, some 60, some 80, some 90, some 100. Okay. So this is how your data would be. So you were the class teacher. You conducted this test. You had 40 students, and each of the 40 students you have the marks for them. Okay. Till now it is clear.
Yeah, that's right.
Now you need to take you need to understand that what is the mean of this 40 students. You can calculate that, no problem. So
That's right.
that's fine, right? You want to calculate what is the standard deviation of this. You can calculate that.
Correct.
Correct. Okay.
Yes.
You know the mean, you know the standard deviation, and you know that marks of the student will always follow normal distribution, right?
Yes.
Correct. So you have all the three things. You have the mean, you have the standard deviation, and you know the distribution. Perfect. No problem at all. Now, suppose you are a teacher, you are concerned about how your class has performed, okay, and you want to make a report to your principal saying that how, based on the marks of the student, your principal will give you compensation or your bonus, okay. So you are really concerned. Now you start analyzing your data, okay. Now first analysis is that my mean of the 40 students is 60 out of 100. That is one. Then you see the spread of the data. That is 5. I mean, overall the standard deviation of my data is 5 out of 100. Okay. So it means if I go into the normal distribution again, for example, uh, okay, like this. So, okay, now uh, just forget these numbers, okay? Forget these numbers. -3, -2, -1. Don't think these are the numbers. I'll just open my drawing tool and mark this. So what was the mean? Tell me, what was the mean?
It's 60.
60. Okay, this is the mean. What is -1 standard deviation? I know the standard deviation as 5. So what is -1 standard deviation? What is the marks here?
Uh,
Your standard deviation is 5,
59
right?
to 59. Yeah.
Not
Yeah, 59 this will
not
be.
-1. This is not -1. This is -1 standard deviation. -1 sigma. So sigma
Yes.
is 5. So this is 55. This is, if see, when I asked you if you had understood this, you understood this, right? This is standard deviation, one standard deviation. It is not -1. It is -1 standard deviation. So 60 minus 5.
Got it. Got it.
Got
Yeah.
it. So this will be how much?
65.
Perfect. This will be how much? Plus 2 sigma.
Yeah, that will be 70.
Perfect. This will be how much?
25.
Perfect. Okay, this will be how much? 50. This will be how much? 45. Got it?
Correct. Yeah, that's fine.
Perfect. So this is understood. So you are the teacher, you have plotted this. Okay. Forget these numbers. Okay. Now you have this distribution, you have the marks, right? Now you understand, you want to know, you know that there are, this is a normal distribution. Now you want to analyze. What you do is you have this marks, you forget these numbers, right? Don't imagine that these numbers are there. You just have plotted these numbers. These are nothing. This is very easy, right? You have
Yeah.
created histograms 45, 50. You have taken the frequency and then smoothen out how we built like this. For example, if you go here, this is 60, this is 55, 50, 45, and so you have constructed this graph, right, with the frequency of histograms,
Yes.
right? Okay, perfect. So yeah, understood till this. Now how do you get this value from here? This you have constructed on your own. Now you want to get this value. How you get this value? You get this value from this. So you want to understand how much standard deviation is 75 away from 60. So 75 minus 60 divided by 5. So that is 3. right?
Yeah, we have already calculated that. Yes.
No, so that's what I'm saying. Don't think like that. First, you have plotted these numbers, then you have plotted the graph. Now you're calculating this. That I was trying to explain you because that time I was trying to make you understand from that angle. Now just think. You have constructed this graph like this histogram. So you had put marks here for 50, 50, 40, 45, 50, 55, 60, 65, 70, right? Like this, you had put the
Right.
numbers and then prepared the histogram and then plotted this histogram, right? No problem at that. Now you want to understand that how many standard deviations is 75 away from 60. So 75 minus 60 I calculate as 3. Now these you are
3.
calculating. Now similarly
Yes.
this is your calculating, this is your calculating, this, so you get all these numbers, right?
Yes.
Perfect. Now I'll erase those numbers because I don't need them. I've already calculated what as I was requiring. Okay. Now, if someone comes and tells you what is the number of people who have scored less than 70, okay, what will be your answer?
Less than 70 all.
No. How can it be all? This was 60, 65, 70. What I've told, this is 70. 70 means 2 standard deviation. Matlab like this. Okay, so this is 70, right?
Yes. So 9.
So
No.
95% plus 2.5. 97.5% people have scored less than 70, right?
And by this, so this is one question. This 68%, 95%, from where we have got this data? Or is this something we need to remember there?
This
So,
is from the Z table. This is from the Z table. Okay. I'll take this after this class. I think other people will want to go ahead. So I'll take this after this class.
okay.
Just understand, these calculations are from the Z table. Once you know these numbers, so you know this is normal distribution, you know these numbers, then this area is calculated from the Z table. Okay.
Okay.
Okay. I'll show you the Z table later. Or if people want, I can show it from the online Google right now. Do you want right now? Other people? Okay, person wants it. Okay, everyone wants it. So I'll just okay. I don't know if you guys can see. Just a sec. I'll do a snip of it. Okay, don't think it's visible for to you guys. Just a second. I can have a better one. Okay. Let's do one thing. I'll just tell you what is what. So basically, okay, let's do one thing. I'll take this after this class and probably add a slide on this for tomorrow's class, and we'll take this tomorrow because I think you won't be able to see here. Okay, is that okay? I'll put that. Yes,
Yes, that's right.
that's fine, right? So I'll put that. Okay, okay. Just uh, uh, let's have a 2 minutes break. Okay, I'll just have some water and then let's continue after that. Okay, let's start again. I'll just put everyone on mute again. Okay, so what I'll do is I'll make some handwritten notes on this and then put it on the slide so that it's easy for me to explain and easy for you guys to understand. I'll probably do that by today, and so that we can have that slide ready by tomorrow. And I understand this is a little difficult for everyone to understand because it's completely new, and also when we learn this is little, we also struggled a little bit to understand what really we are trying to do here. Don't worry, we'll get this through, and I'll prepare a slide with my handwritten notes and mark it up so that you guys can understand how. So this is a general definition. What is a vector? So vector is something which has a sense of magnitude and direction. This is very basic physics. Why we are trying to have this here? This is, we'll get to that, but just for now, just understand. This is if a vector lies like this, and then this, then the resultant vector is square root of addition. Square root of the additions of the squares of each. So I think no need to spend much time on this. This is the slope of the vector tan theta. So this is general maths. No need to understand too much here. Just understand what is a unit vector or a scale vector. So anything which is divided by its magnitude. So these signs means the magnitude of the vector. So u is something use a scalar unit, which is has a direction, not a scalar, it's a vector, which has the direction of the v but has magnitude as 1. So why we are trying to say, why we are trying to do this here is basically when you are trying to model so many things, right? So for example, if you have multiple variables in your model, some variables will have, for example, if you're trying to build a model, let's say, um, based on the income and the age of the person, you want to predict whether he will buy a very high society building. How he'll buy a house in a high society building, or he'll buy somewhere in middle medium society kind of thing, or he'll buy a house in a normal, very low standard society. Okay, so you have classified three classes, and you want to predict whether what class he will fall into. For example, you are inputting the age. So age is, let's say, 26, 27, or let's say it will go up to 50, 60 max. Income, if in, let's say if you're doing in US, it will range from all the way from $20,000 to, let's say, 1 lakh dollars or $1 million. Anything can be, right? Or even multi-million dollars. That can be the range. So when you're trying to form a model, there's one quantity which is in thousands or lakhs or millions, right? And one quantity which is in tens. So your model will really get confused with the scale of the income, right? It'll say, oh my God, this is such a huge number. I mean, a multi-million dollar and $1 million itself is, I mean, some X or Y times, okay? Or for example, if someone is on $20,000, and if you're comparing with someone who is, let's say, $1 million, so it's a huge difference, right? But the age variation is very less. It can be till 26 to 50 or max 3 times 81 or 80, right? So your model will always think that price is very important, or sorry, the income is very important and age is not important. However, that may not be the case, right? If someone of even of a very high income, let's say if he is in on the verge of retirement, he'll not buy a house, let's say, on a very big society right now, right? Whereas some person who is in the mid of 30s, he's just like in the middle of his career, he has a lot of money that will be inflowing in the future. He can invest and take a probably a good home loan and buy in a very high class society, right? So age will make a difference. So that's where your scaling comes into picture, right? You don't want the model to get confused or influenced by numbers which are very big in magnitude compared to others which are small in magnitude, right? So this is where your min max scaling comes. So basically it's a very simple formula. Whatever your data is, just subtract from your minimum and then divide it by the range. Okay, so your maximum will be 1 and your minimum will be 0. Okay, it's a very simple concept. No need to uh, think too much about it. I've explained you why we are doing this, or why we should do this. So this is a very simple code. I'll not waste too much time in writing the code. It's a very important, it's a very simple code. So this is a package. So for example, what we did, like import pandas at PD. So right now we are doing from sklearn.preprocessing import min max scalar. This is the function name. You're having a data frame. Okay, now it's very important to know this, that sklearn will have all the packages that are applicable on a data frame. You cannot, most of the packages or the functions of sklearn, or sklearn is the package name that we discussed, like numpys and matplotlib, last time what we discussed. Sklearn is again the package name which contains a lot of machine learning functions and packages. So sklearn, most of the functions of sklearn are to be applied on data frames and nothing else. Okay, no lists, no dictionaries, no vectors, no numpys, only data frames. So whenever you're trying to apply this, just have need to have a data frame. Okay, so so this is your data frame. This is your function. So you're storing the name of the function in a variable, and then you're just fitting that into this data frame, and then you're just transforming this. So fit and transform is a necessary step you need to write every time. So once you fit and then you transform, every time it comes in couple. It comes in a couple. Okay. So when you do a fit, you need to do a transform, and then your transfer. So one, what is the minimum here? 1 is the minimum, right? So 1 minus 1 divided by the range. Range is 5 minus 1, 4. Okay. So 1 minus 1 divided by 4, 0. 2 minus 1 divided by 4, 0.25. 2 minus 1 divided by 4, 0.25. Similarly, all this. 5 minus 1 divided by 4 is 1. Any doubts here? I think it's very easy. And if you need me to write the code, but I mean, I think it's a very easy code. Okay, so I think everyone is clear on this. So right now we talked about min-max scaling, right? There can be another type of scaling called max absolute scaler. So what it does is divides all the values by the maximum absolute value. Maximum becomes 1 to minus 1. Minimum value gets divided by the absolute value of max. So here you don't have negatives, but for example, if you would have a negative, you still take a absolute value, right? So you divide all the values divided by the maximum absolute value. Okay. So for example, if this would have been minus 5, you still would have taken 5, and then 1 divided 5, 5, 2 divided by 5, and so on. So this is again the same thing. You're importing this function, you're making a data frame, you're storing this function name in a new variable, and then you're fitting it, and then you're transforming it. Okay, no questions here right now, right? Everything clear? Everything clear for everyone? Okay, thank you. So let's proceed. Okay, so as I told you, this is minus 5. So you'll still divide it by plus 5, and then 0.2, 0.4, 0.5. But this number is minus 1, right? So when you are dividing it, you take the absolute value and you divide by the whole data by that number. Okay. Now you can also do a binary threshold. Okay, so for example, you're taking this package, again importing the function, you're taking the data frame, you're storing the function in a variable, you're doing a fit and transform. What is important is the threshold function. Sorry, threshold parameter. Threshold means whatever comes beyond the threshold gets classified into one, and whatever comes below the threshold becomes zero. Okay, very intuitive, very easy to understand. So whatever comes below 3 is 0, whatever comes above and equal above 3, it becomes this thing becomes 1. Okay, so no nothing, no problem in that. Okay, now how is 3 Sharad, I think if you see this, less than equal to becomes 0. So whatever you put 3, 3 is less than equal to yeah. So 3 is less than equal to 0, and 3 is less than equal to 3. So it is equal to 3. So it becomes 0. Okay. Sir, this threshold is 3, just an example. You can put threshold 4 also. So that is the requirement of the user, and not the requirement of the data. So it is just for you to understand, or for you to make sense of it. Okay. So for example, if you if you could say the same example, what we talked about is about the income of the people. What you could say, you could take an average income of the people in US and then take that as a threshold. So whoever is above threshold of the average income, he can be classified as rich, and someone who is lesser than the average person, he can be classified as middle class. So something like that. Okay, so that threshold and interpretation lies with the user. Okay, so we understand this. Okay, now this is very important. You have your data, you pre-process it. So whatever we did till now, like understanding the distribution, scaling it, this is all about pre-processing, falls under pre-processing, right? So you pre-process the data, you scale it so that your variables don't get influenced too much by a single value. Then you fit the model, then you check your accuracy, then you re-feed that accuracy thing to the pre-processing, and then this is like a cycle, it goes on. Okay, and then you do a prediction. Okay, so once your model is ready with this cycle, then finally go into prediction. Okay, so the vector that we talked about in the last this thing is kind of so each row is a vector. Okay, so each row is a vector of features. So feature 1, feature 2, feature 3, feature 4, each row is a vector of these features. Okay. Just to make you understand. And this is a statistical series. This has nothing much to do with understanding of the data frame, but just remember what is a vector. If someone asks you what is a vector, each row is a vector. Okay. Now, now let's enter into machine learning. So I think Sunil and Sharad were there last time, but since Vasant was not there, we'll just reiterate to the definitions and so that we get a feel of it, and then we'll go into linear regression into a lot of depth today, so that it is crystal clear for everyone. Okay, now let's start. So machine learning, I think the definition is very simple. Is something which the computers are learning from the experience without being explicitly programmed. So explicitly programmed as in you don't want to tell the machine everything. So for example, if there's okay, Sunil has some question. Uh, yes, Sunil, tell.
Hello.
Yes, Sunil.
Yeah. So this definition I have seen. So what machine learning is that without explicitly programmed, it will give you the answer. But assuming if we have n numbers for which we have the data,
Uh-huh.
we have trained for that one, and we are giving n plus 1th data
Okay.
for which we are expecting the answer.
Uh-huh.
So that answer can be wrong or right.
Correct.
So what about the n plus 2th? Are we again going to feed this n plus 1th to the data training set, or how it will go ahead?
Okay, that's an excellent question. I think Sunil, that's a very good question. So I think I answered this in one of the classes. I don't know, remember who asked this. So your model update, okay, model update is something which you should do every day, or every time you get a new data, you have the prediction, you update that into the model, because that is something which your model has not seen. Whatever data, so whenever you're doing machine learning, right, the first and foremost thing for machine learning is get as much data as possible without thinking anything. Get as much data as possible. Okay, so I mean, whenever you're getting a new data, that is more information to the model. So as soon as you get a new data point, just feed that into the model. I mean, feed that into the data, add that into the data. However, when you are doing in actual real time databases, it is very difficult for someone to continuously append data, right? So there needs to be a program that needs to be run every second to update. So there's a lot of cost involved that. Okay, so here comes the trade-off. There's a cost involved with a regular update, and there's cost. I mean, and then there's a benefit of having more knowledge to the model, right? So you have to balance out. You need to see how often you should refresh your database so that your model gets updated, right? You cannot do it every time because it's a very costly affair to update your database every time, because your servers are usage is every time you use your server, it is being monitored. It is you are paying a cost for that, so your servers cannot be occupied every time. But having said that, whenever you get an opportunity to do that, you should do that. Does that answer your question?
Yeah, that's fine. Thanks a lot.
Yeah, sure, no problem. Okay, so I think we are clear on this. So I think this slide also we have seen. I mean, we'll not uh, go through much of this. Any doubt if you have on any of the examples, you could stop me. We have seen spam filtering, stock price prediction, movies as a recommendation, mobile check for deposit, in fraud detection, face recognition, in deep learning, face recognition. You can identify. So what your Apple iPhone X I think has, it has one of the best face recognition softwares. It is using machine learning and AI for that. Facebook when it tags, whenever you see you update a photo with of your friend, it gets recommendation that if you want to tag that person, it knows that this is the face of this guy. So I think a lot of face recognition softwares are available. Voice to text, whenever you like your interpreters, your translators, all work on this. So I think we have all seen these examples all earlier also. Okay, now here comes a very important part. So I think people who had attended this class last time, they might have a good I understanding idea of this, but I'll still reiterate this. So supervised learning is type of learning where your data or your training data has already been marked by someone who has collected the data. For example, let's go back to the example of a height and weight, right? So whenever you're trying to take the data for height and weight, each of the height and weight has been marked whether that is a male or a female or a male or a female. Okay, so this all data has been marked. Okay, so whenever you want to predict, you get a new height and weight, you want to predict whether it's a male or female, right? So your machine will understand from the past data of height and weight whether this guy is a male or a female. Okay, so that is supervised learning. Now male and female we have already talked about, right? That is called a classification problem where the outcome is limited. Outcome is limited to certain classes, and the classes don't have any let's say what you can call is, there's no hierarchy in the classes. For example, male and female, no one will say male is greater than female or female is greater than male, right? So there is no particular hierarchy in your classes. Each of the classes, for example, let's say you have a win or a loss. Okay, yeah, Sunil. Yeah, this is a binary classification, male and female. That's what I was saying. That is a classification problem with the two outputs. There can be a classification problem with three outputs. Then it falls under the multi-classification problem. Okay, so this is a classification problem. What is a regression problem? Regression problem is where you are trying to predict a continuous output. Okay, so, for example, if you're trying to predict the age of a person or his income, or let's say, what will be the price of the house he would buy in future? Okay, so you're trying to predict a continuous output, a number, and not a class. So that is supervised learning. Now, unsupervised learning is something where your output is not known in your training data. For example, to just have this understanding easy, I am again taking that height and weight example. For example, you have collected height and weight, but you forgot to mark who was a male, who was a female, right? Now you, so Neil asks why we say continuous output and just not just a number. Continuous output, what I mean is a number. So you're right, it can be an integer, it can be anything in a real number space, right? Continuous, why we are saying is that, for example, you have your data, for example, your data has ages of people of 26, 28, 30, 35. Suddenly you want to predict for someone, your output comes up as 31, right? So for example, that's a good question, Sunil. So I think I would love to explain this. For example, let's say you are trying to do a problem where you want to predict whether the person age is 26, 30, or 35. These are three numbers, right? Now there can be two interpretations of this. You call these three numbers as classes, okay? Class 26, class 30, and class 35. Then it is not a continuous output. You cannot predict someone of 31 age. Your model will always give 35, 30, or 26 as an output because it is understanding that this is a three class classification problem. But why I say that is a continuous output. Continuous output means anything, any number can be predicted between whatever the data has seen. So, for example, if your data has seen someone from 26 to 50, it can predict someone of 40, or let's say it can predict someone of 70 even. Okay, but a classification problem, it can be, for example, movie rating, or let's say whatever IMDb ratings are there. IMDb ratings are not, I mean, ideally it should not be a number, right? They give averages 8.5, 8.6, but ideally it is not a number, because a movie of 9 is not exactly 1 point lesser than a movie of 8, right? It is kind of what notion you create of that ratings, right? Is, let's not get into complexities of those, but just to make you understand, uh, these numbers of movie ratings do not make actual sense, right? So your IMDb rating 10 minus a movie IMDb rating of 9 doesn't give you a movie IMDb rating of 1, right? So these numbers are actual representations. So these are classes. These are not continuous outputs. Okay. So just to make you understand that numbers uh, need not be continuous every time. The numbers can be the notion. Okay. So based on that notion, there is a insight that you get. But that's why I said continuous means a whole range of numbers. You can predict anything, any decimal point, anything in between those numbers. Okay, is this clear to everyone? Okay. Okay, so everyone is clear. Yeah, so what I was discussing is unsupervised learning. Now, unsupervised learning is type of a learning wherein, as you would have understood, that you forgot to mark your output. So you have collected the data, but you forgot to mark who was male, who was female, right? So now you come to your boss. You said that, I have marked the height and weight, but I'm sorry, I really forgot to mark who was male and female. So what will your boss do? Your boss will tell, okay, do whatever you have and do an analysis on that. Okay. So what you'll do, you'll plot it. Okay. So you plot the height on x-axis, weight on y-axis. There will be certain distribution what you will see. For example, let's get that graph, clustering. Where is that graph? Yeah. So, for example, here are two groups. Here are four groups, but for example, you have plotted height and weight, and you just get two groups. One on the top right, one on the bottom left. Okay. You're very clever. You understand. Okay, I think your top right is male, and your bottom right is bottom left is female, because on an average males will have a greater height and weight that are compared to their female counterparts, right? So this is what is unsupervised learning. You didn't know the output, but you had an insight from the plot that you could get, right? You clustered it, you collected them, classified them into groups. These groups can be interpreted in a different way. If you, in this case, you know that this could be a male or female, but in many cases you don't know what groups are there existing in your data. For example, uh, if you are sitting in a clinic all over the world, for example, you are sitting in a clinic where people from all over the world will come, then you will get confused whether this top right corner is a male, or is it an Australian, or is it an African, or whether the bottom left is a female, or is it an Indian. So in that case, it is very difficult to take insights of these sorts, because you really don't know what you're looking for. But you can, due to your business knowledge or your understanding of the data, you can come to insights. Okay, so we'll look into that later. Let's get back to what we are trying to do. So I think this is a very general example. So you want to predict whether that, if you know the outlook, if you know the temperature, if you know whether it is windy or not, You want to predict whether children will come out to play or not. Okay. So based on the outlook, you have a output, and this output is of two classes: no, yes or no, right? So there's no third outcome. There's no possible third outcome. Okay, now I think this is very clear. So we've already discussed this. Now this is very important. Okay, listen to this very carefully. You have your data, right? This data has been generated by some function. So for example, let us think like this. When God made a man and a woman, he might have something in his mind, right? Some calculations he was doing that, okay, when I'm creating a male, I should give him an average height or weight of this. When I'm creating a female, I would give her some features like this. So God had some function in his mind, or let's say some notion in his mind while he was assigning height and weight to male and female, right? As a person, you don't know that, right? You can only get as close as possible to your God's function, but you cannot estimate the exact function. So what you're trying to do is you have a function which is the absolute truth. There is no two way around it. There is a function which is an absolute truth. For example, let's just talk about stocks. Okay, the stock prices, many people say it is random. For example, an average layman like me, I would say, I don't know. Stocks will move like randomly. I don't know where to invest. But a person who has, spent 15 years in investment banking, he knows a lot about how stocks are moving. He has a lot of knowledge that based on what Donald Trump says, based on what a company's product, I think these stocks will move somewhat like this. But still, he is not 100%. Certain things there is he doesn't know. Someone who has worked in investment banking for 30 years will know much more than a person who has worked in investment banking for 15 years. So he knows that, oh, this stocks will move also because of this, because of market sentiments, because of crude oil prices, because of, let's say, what are the policies that are there, right? What are the policies that import export policies that Donald Trump is introducing? So he knows all these things, but he can be as good as his knowledge, right? He is not God. So there's an inherent function that is determining the stock prices, that is calculating the stock prices. But you, me, or yeah, I mean people like us, or people in general, who are like not God, we don't know that function, right? We don't know what is generating the stock prices. What we can do is, you have the data for stock prices, you do your machine learning and statistics and get a function called G as close as possible to F. Okay, we cannot ever go into F. There's a very less probability that we'll go to F, but some certain cases you can go to F if you know the F, if you know somehow how your data is being generated. But 90% of the times you don't know how your data is generated. So you're trying to guess. Okay. So any doubts still here? I mean, is this corollary clear? I mean, whatever example I gave. Can I get a yes or no on my chat box? And if anyone has question, I can unmute. Okay, clear. Everyone is clear. That's great. So classification regression we have already seen is a list of values. Regression is a number. Okay. Supervised learning we have seen. What is a guess? We have all seen this. I don't think this needs to be checked. Email is spam or not. We know it's a two-class problem. Classification, stock price is a regression, house price is a regression. Person is diabetic or not is based on a classification. Okay, so I'm not going into that here. Unsupervised learning we have seen, we don't know the outcome, we try to break into groups, and that's it. Okay. Now, your supervised learning can be of different types. Okay, there can be linear regression, there can be polynomial regression, there can be regularization. Regularization is basically concept; it is not a model. It is more of a concept, and then there are models called Ridge and Lasso based on your this thing, based on the regularization. Okay, now let's say this. Okay. Uh, Now, suppose suppose you are given the data of your house. Okay, house price versus the area it covers. Okay, so let's say this is some 300. I mean, whatever area it is, and this is the 100 units, and then you have prices of the houses. Okay, now you collected data, you have collected did a lot of data collection. Now you have plotted. Okay, so there are 1 2 3 4 5 6 7 8 9 10 11 12 13 data points. You plot the data, right? Now you see that, okay, this data I think is kind of a linear. Can I draw a straight line through this? This looks good, right? A straight line through this. Now some you show this to your boss, the boss says, no, I think this, the line which is good, I think this is the better line. You show it to your colleague, he says, no, I think this is the better line because it covers most of the data points. So you get confused. Oh my god, there are infinite number of data lines that are possible through this data point, right? I mean, what to do? You come up with something called a linear regression model. Okay, so essentially what it does is it will fit a line to your data. Okay, your line will always be of the form of y is equal to a plus b x1, sorry, b1 x1 b2 x2, so this will go on, right? b3 x3 and all. So y is a function of some intercept and features. Okay, so these are the features. So x, for example, in this case what we are trying to do, we are trying to predict the house area equal to some intercept plus some coefficient into the house price. Okay, so what we are trying to do is we are trying to predict the area of the house based on the price of the house. Now this is your function, but how do you get to know this and this? Okay, that is the task, right? If you know this and this, then everything is over, right? So what you do is there's a concept called root mean square error. I want to draw a line which is closest to all these points. So this will be at I mean, don't go by the drawing. Okay, so so this will be always parallel to y-axis, perpendicular to x-axis. Okay, so these lines are parallel to y-axis and perpendicular to x-axis. So what is the distance between this point and the line? Okay, all these are parallel to y-axis and perpendicular to x-axis. Remember that. I'm not able to draw that properly because I'm using a mouse, but Sorry, so this is not there, right? So till here. Okay, so you want to draw a line so that the sum of all these distances is reduced or the minimum. Okay, so for example, if all the points lie in the line, you could simply draw a line like this and you say that the distance, sum of this distance is 0. But in this case, there cannot be a single line that goes all through all these points, right? There will be a line which has the lowest distance from this, right? And that is a line what we are trying to predict. So I'll delete all these things. What is your cost function? A cost function is something very important in machine learning. It is trying to find out the parameters like what we described here, C and B, is trying to find out those parameters based on some function. So let me mark these points as y actual. Okay, that is the actual data, and then y hat as the predicted data. So whenever, so y, what is y hat? Y hat is C plus beta into the house price. So this, at this house price, you put that into here, beta times plus C. Beta and C, remember, you don't know, right? So this house price has a y hat predicted, but you don't know C plus B. So best you can say is y hat is equal to C plus beta into 100,000. And then there is an actual here already, what which is you have collected. This is 100. So this is 100 minus brackets C plus beta into 100,000, right? You get the point. I'll not draw all the zeros. Okay. Similarly, this point will have actual and a predicted. This will have actual and predicted. So now y actual minus y hat square. You remember why we did a square in deviation? So there will be a positive errors and there will be negative errors. Some will lie below the line, some will lie above the line, right? I don't want such a line which is kind of cancels out your positive and negative sign. I want a line which is lowest from each of the points. So I will add them. This is a sigma sign. This is for addition. Add them all over the points and minimize this. So this becomes my cost function for linear regression. Now I'll stop here. Does anyone have any doubts till now? I'll unmute you guys. Anyone has any doubts here? Sunil is okay. Sharat and Vasant, this is very important. If you have any doubts right now, please let me know because this is very important. Sharat, Vasant, can you please let me know whether you have any doubt? Can you drop a chat? Okay, Sharat is okay. Vasant? Okay, Vasant is also good. So I think that is a very good thing. So this is what we are trying to minimize. Okay. Okay. So let's open your Jupyter notebook and let's code this out. Okay. Let's open your notebooks. Okay, import pandas as PD. As we remember, pandas is a data frame. I mean, pandas is a package for the data frames. Why I told data frame? Data frames are a way that your data is to be input in all the models. You need to have everything in data frames so that you can input that into the model. Okay, so X is the predictor variables or the features, and Y is the prediction or the training or the supervised output. Okay, from sklearn is the package. Import linear model. Linear model is the model. Inside linear model, there's something called linear regression. Okay, so linear model dot linear regression I'm storing into regar. It is just because I want to have, I mean, in future use I want to have a simple name, to use. So that's why I'm storing that into this variable regr.fit xy. Okay, so basically I fit my model. So this command, right, this command will do all the calculations. uh, Imagine how powerful your Python is, right? You had to calculate this, you know, the squared. You have to add it up. You had to differentiate to get the minimum. Then you had to, I mean, that the whole process is being run by a single line. regr.fit xy. Inside this, there are a lot of calculations that goes into, but we don't need to look into that because we are not going to develop packages. We are going to use them. So this is what this line will do. And then you are using the predict function on your data frame to predict the values. And these are the predictions. Okay. So you see here how your model has, beautifully fitted. So for example, 0 1, so there's a difference of 1. 1 3, there's a difference of 2. 2 5, there's a difference of 3. 3 4, there's a difference of 4. 4 9, there's a difference of 5. 5 11, there's a difference of 6. You predict for 6 7 8. 6, it predicts a difference of 7. 7, it predicts a difference of 8. 8, it predicts a difference of 9. That's how intelligent. So now, why this is perfectly fit? Because this was a linear model. Now if I put some weird numbers, I don't follow the pattern. Let's say I do 8 or 9, or then let's say I write 200. Okay, now if I run this, it takes a little time to run. So this asterisk means it is running, right? Okay, by the time it completes the execution, I'll just take a 3 minutes break. Okay, I'll get back to you guys. Meantime, it will just Okay. So see now there's two things. Okay, guys, you can hear me, right?
Yes, Sukhdeep,
Yeah.
it's giving error for me.
Okay.
Regression.ptxy.
Okay. Okay. We'll see that after the end of the session why it is giving error. Just go through the syntax once if it is, and we'll see the error later. Now, I wanted to let you guys know, or show you one thing. So you see here, your whole data is 0, 1, 2, 3, 4, 5, and then there's y called 13589. Okay, and then there's 1, 200, and you see how your predictions have changed drastically. Now this is what is an effect of an outlier. Okay, you know that for 0 it was 1, 1 for 3, 2 for 5, 3 for 8, 4 for 9, 5 for 200. This is an outlier, right? This probably it could be a wrong data entry, or it could be some weird observation which is not exactly possible. Hmm? You see how it has gone haywire in predicting 678. It's predicting 139, 168, 197. So that's why the data pre-processing and you know taking out outliers is very important. So, for example, uh, if you see here, so for example, if you see here, when I draw a line like this is good. But what happens if there's a point somewhere here? The model will also try, when I draw a line like this distance will be huge. The model will try to reduce that distance. So what will happen is it'll start drawing a line from here. Maybe that distance was more than these total distances, right? So the line will shift, and that's why the prediction goes wrong. So removing outliers is very important, and sometimes this can define the difference between a good model and a bad model. Okay, so you get this essence, right? So everything, I think till now it has been very smooth, right? Any doubts till now? Sunil says how to remove outliers. We'll come to that. There's a separate topic for that. We'll come to that. But so Sharad says no. Okay, he doesn't have any doubt. So Sunil, so for example, uh, there's some. So when we discussed about distributions, right? So when we talked about normal distribution, and we talked about the percentages. So remember, we were saying that this person is within 95%, or the between 95 to 100%. For example, there's a class student. Your students have scored around 60 to 70. The same example. There's one student here who has scored 0. Okay, the average, the lowest marks beyond 0 is 40, but there's one student who has absolutely scored 0, right? So there could be two chances: his paper was not corrected, his he was absent during the test, or he never studied anything, so he landed up in India having a 0. But you don't want to, you know um, you know uh, you don't want to tell yourself as a bad teacher just because one student has scored 0, because for you that is an outlier. That person did not study, or he was absent, or his paper did not come to me. That's not my problem. I mean, I as a teacher didn't go bad, right? It was some fault of the system. So how did you decide he's an outlier? So if someone is beyond, very beyond the average, right? So very away from the average, a lot of standard deviations away from the average, then that guy is an outlier. Now remember when I discussed mean and median, I said median is robust to outliers and mean is not. So taking a page from that discussion, right now what we are trying to say is a person who is very away from the median, lot of gap between the, let's understand this, lot of gap between the median and that person particular data, then that guy is an outlier. Okay, how exactly to define that, how exactly to remove that, we'll see that. But for now, just understand like this. Is it good? Are you comfortable? Okay, so Neil is good. So I think we have progressed a lot of things today. That's great. So we have seen this also. Okay, now I think we have already talked about what cost function is and what is okay now. Okay, now just focus on what I draw here. Something to do with a gradient descent. Imagine you have a bowl. Okay, you put a droplet here, water droplet. Where will the water droplet go and settle? It will travel like this and it will settle here, right? The minimum point. Okay, take this corollary and understand this. This is your function. This is where you are right now. What you're trying to do is you're trying to adjust your parameters, your c and beta, what we discussed in that y is equal to c plus bx. You want to you want to if get to a point so that c plus bx, the combination of that gets you to this point where your error is the minimum. Okay, so this travel, or you can point, your point can be here also. So this travel is called gradient descent. Okay, so your function tries to achieve the minimum value and you are going to go into that direction. So how you go, you calculate the slope. What is the slope? The slope is this, the tangent here, right? You go into the direction of the slope. So whatever your slope says, you go into the direction of that slope. Now for example, this slope is saying it is like this. How far you need to go? Do I go 100 units at drop and go here? Again, I'll come here. Then again, my slope will change. Again, I 100 units I'll go here, and again I 100 units I'll go here. I'll do like this, right? I'll never come here. So there's something called a learning parameter. Okay, we'll just register this in mind right now. We'll try to understand each of these things as we go and progress, but try to register this. There's something called a learning parameter. So you know that you need to go here, but you take baby steps. You don't jump. So you go here. Okay. Then you again calculate the slope. Your slope still says here. Okay. You take a baby step. You go here. Then the slope has reduced. The slope is say that you need to go some, not very steeply now, but somewhat. Still you have to go left. You take another baby step. Now you say you again calculate the slope. Your slope says you have to go here. You take a baby step. Right, like this you reach your minimum of your cost function. Is this good? Tell me if you have any doubt and we can restart. I mean, I can re-explain the concept. But this bowl and droplet is a very famous example that is being used for gradient descent, and when it is very intuitive to understand. So just drop me a message whether you have understood this concept or not. So gradient descent is basically a concept on how we are trying to reduce the error. Okay. Sharad is good with this. Vasant and Sunil. Okay. So Vatsant has this question: is this to calculate the minimum point? Yes, this is to calculate the minimum point. Sunil had this question. It was very a good question. He says, how to do this? How do you calculate? How are you calculating the slope? So when you're differentiating, when you differentiate, you get the slope of the function, right? The first differential of a function is the slope of the function. So whatever sign that slope gives, according to that slope, according to that sign, you have to go in that direction. So whatever sign you go, according to that, whether you have to decrease or you have to increase that direction, and then the baby steps, the amount of steps you need to take, that is the user tells. So for example, I can say my learning parameter to be zero point 0.2 zero point 0.2 units I need to. So normally a learning parameter will vary from 0 to 1. So if it was 1, then it is huge. I'm taking huge steps. If it is 0, I'm not moving at all. So somewhere between 0 to 1, I have to move so that I can reach my minimum. If it is too high, then I keep on bouncing here and there. If it is too low, then I take a lot of time to go to the minimum point. Does that answer your question, Sunil? Sunil, partially. Okay. So, okay. So after probably we'll close the session in 10 minutes. After that, we can have some questions on what we need to understand here. Okay. So, okay. Now, the linear regression, what we had talked about. So, the example I gave you was based on a single feature, right? But you can have multiple features. You can have, for example, you were predicting the house area based on the price of the house. You could have the area of the house based on the location. You could have the area of the house based on the number of rooms it has. So there can be many features, right, to predict. And the more the number of features, the more information you're giving to the model, and the more better will be your accuracies. Most of the times, this is not a single statement to understand. Again, it is very important to understand. Most of the times, more data means more features means a good model. Okay, there can be certain. For example, if I input IMDb rating in a movie and trying to use that knowledge to predict the area of the house. Will that make sense? Not, right? It doesn't have any correlation or any sense in predicting the area of the house, right? So it's very important to, you know, have this concept of features, whatever features you want to, use for the model. But that that is under a different scope. We'll not see that particulars. We'll go into a little overview of feature selection, but will not go into depth of what features we need to select for a particular model. But you could say that if a data has, if your predictor or your feature has some correlation. Do you guys understand what is correlation? Correlation is basically, let's say, how two things move. Okay, so for example, if x increases, does y also increase, or does y decrease, or it doesn't have any effect? Okay, so correlation basically lies between -1 to 1. So one correlation means 100%. So if x moves, y also moves in that particular direction. Okay, and if x moves, then y moves in that particular direction, but not that much. It can be 0.2 or 0.3. Okay, so, and if it is minus, it means x increases, y decreases. So that is the essence of correlation. So you need to understand that how your X and Y is correlated. But there's something called confounding. It's a very important concept in statistics. It's not there in the slide, but listen me out on this. It's a very interesting. For example, there's a study called, um, for example, you have a ice cream setup on a beach, okay, and you are on a beach where you know the beach has a lot of sharks, okay. Now there can be a study. I went to the beach and I collect data on the ice cream sales and the shark attacks. So when I do modeling, I would say the number of sharks attack are dependent on the ice cream sales. But does this make any sense? Doesn't make any sense, right? How can ice cream sales be related to the shark attacks? What is the confounding thing in here? Is the number of people visiting. So if your number of people visiting is more, then your ice cream sales will be more, and the number of people venturing into the sea will be more, and hence the shark attacks, right? So the confounding, you can have correlation. Your ice cream sales are increasing with the number of shark attacks. That there is a correlation, but there is no causation. Okay, so there are two important things here to understand. One is association and one is causation. Correlation will only give you association. It cannot give you causation. In fact, nothing can give you causation. You don't know what is the cause of anything, right? So maybe I'm saying that number of people visiting is the cause of your increasing sales of ice creams and increasing sales, increasing shark attacks. But what is the cause of people coming in? It may be the weather. It may be that people have a lot of excess money. Okay, Sunil has question. One is correlation related to association. What is the other one? It is causation. Causation doesn't have any parameter. Okay, I cannot uh, quantify causation. I cannot say that this is the cause of this. Cause and effect. There are okay. Causation is cause. C. Okay, I'll write it down. Causation is. I'll just write it down here. Okay, causation. CAUSATION. What is the cause? So shark attacks cannot be the cause. I mean, ice cream sales cannot be the cause of shark attacks, right? Okay. Now, so we have understood this. We have understood correlation. A lot of things have happened today. Uh, we'll go a little further, and then probably we can stop so that we don't overload you guys with information. Okay. So we all know this. What are coefficients? So, for example, if you want to predict the per capita income, so you have year, and then you have GDP, and then on the basis of that, you are predicting per capita income. Okay. So, okay. So any model for which you want to, so in the model what we did in our notebook, we printed, we got the output. Now if you want to print the intercept or the print the coefficient, this is how you do it. Reg r dot intercept and reg r dot coefficient will print the uh, intercept and the coefficient. Okay. So this is how your model will look like. So, for example, if your year and GDP, you are predicting your per capita income. This is your intercept. This is the intercept. This is your X1. Okay, X1 is 81.768, and this is your X2. Okay. So scikit-learn, we will not go into much of this. Scikit-learn is basically, having all the repository of machine learning algorithms. It is so sklearn, what we did, right? Sklearn in our code. This sklearn in code. This is all. This is what we call as scikit-learn. Okay. So lots of internet resources, and so we showed you, right, how powerful it is. Just a line of code will do so many things. Okay, so create estimator, load data. Okay, now I think we can stop here um, and address some of the questions, because these things will take up to tomorrow, so that we have continuation. And tomorrow then we'll see what are hyperparameters, what are the linear regression hyperparameters, what is a polynomial regression, what are the some examples of the polynomial regression, and then we see regularization, what is regularization, and we go into region lasso. Okay, so I think we'll stop here today. Now I'll unmute you guys. If you have any questions on today's session, we can address that. So Sunil had a question. We can address this together. Just a second, I'll unmute you guys. Okay, so I think the forum is open for questions. Anyone wants to start?
So, basically, we have different attributes, as like if you take the house prices, number, area size, that is one, number of rooms, kitchen size, number of bathrooms. There are many attributes.
Correct.
Which is affecting your overall price. In mathematical terms, these attributes are x1, x2, x3, x4.
Correct.
So how we will decide which attributes we have to take care and which attributes we can ignore?
Okay.
So is there in Python or some other library which can let me know?
Okay. So every different model. So, for example, we have talked about linear regression, right? So every model will have some or the other way to understand what attributes to keep and what attributes to leave. For example, in linear regression, let's get back to the equation we saw.
I think so that was y equal to ax plus b.
Not this one. Okay. See this one.
Uh,
So what does this mean exactly? Now, before this, just keep this in mind. What I talked about about scaling, right? Whenever you are doing a feature selection, this process is called feature selection, whatever you're asking. So whenever you're doing a feature selection and regression problem, keep in mind that your features should be scaled, because if you remember what I said, you don't want a feature which has a bigger unit to ignore someone who has a smaller unit just because of the unit. It may have a lot of information, but you are ignoring just because the unit is very high. Don't do that. Okay, I'm giving an example here because this is the equation that I have right now. But whenever you're doing a linear regression, always scale it properly. You can use a min max scaler, you can use a max app scaler, any scaling, but you need to do a scaling there. Okay, now imagine after scaling you have this output. Okay, now what does this mean? Forget this intercept. So these are the features. So normally a unit increase in a year increases your per capita income by 81.7. A unit increase in GDP increases your per capita income by 7.3. Now, imagine if this would have been 0.73. It means a unit in GDP, increase in GDP, is increasing your per capita by 0.73. It means it has almost no effect. Okay. So imagine if it would have been further low, 0.073, it means it is negligible. My per capita, I am talking in thousands, and this guy is just increasing with 1 unit, it increases just 0.073. So I may as well neglect this. This is not even adding anything in my model. So when you have a linear regression, so when we discuss ridge and lasso, right? So ridge and lasso is kind of a feature selection of linear regression. We'll go into detail on that. But for this particular example, just keep in mind, you see the coefficients, and if the coefficients are too less or too low, you can assume that particular feature does not have much effect to the output.
okay, great.
Okay.
Okay, so assuming, sorry.
Yeah, tell.
So assuming based on this mathematical function, Everything we are deciding, and there is a Python library which is giving our coefficients whether we need this feature or not. So what about those diagrams, bar chart, or we draw basically? So
bar chart about what? I mean, so what?
No, I mean, okay. So means how it goes in a sequence. Basically, I'm thinking if this is the problem, if for a particular year or size, you have to get the price. So one data we have got. Then what is the second step? Draw the model and see how it's distributed, or just the second step is that to go and use the scikit library, MCAL.
Okay, that's a good question. So whenever you get the data, first step is to data explore. Okay, explore the data. How does your data look like? How does your data look like in a 2D plot? Now, when you have thousands of features, that is difficult for you or for
In 2D plot.
visualize, right? Okay, so
Yes.
that's when you do something called follow the Occam's razor. Occam's razor is a statistical principle wherein every statistician starts with a simple model. Start with a linear regression. See your accuracy. Move on to the next model if your accuracy is not. So, for example, if you get something like 90% accuracy, now move on to the next model. See what is the accuracy. If your accuracy is improving, it means there is still scope to improve the model. If your accuracy is decreasing, then you have already fitted the best model. Okay, so that's how you typically follow, the modeling part. Now, before that, you have to process the data, right? So pre-processing, as I told you, have to clean your data. For example, if there are missing values, you have to remove those missing values. If there are outliers, you have to remove the outliers. If there is scaling required to be done, you have to do the scaling. Then if you have to do a feature selection can only be done, one, by the correlation analysis, but the correlation analysis is not always correct. So you go into the model, go into linear regression and see that whether this parameter, this coefficient is large or small. Then you do a feature selection, then you start on building different models. That's how you progress typically. And then, so displaying your output or creating graphs is not very important for a data scientist. That visualization part is more of a diagnostic analysis. You are dealing with predictive analytics, right? So I don't want to see the visualization. Don't want to see a bar chart or a histogram. Tell me how your output is distributed. Tell me the outliers. Tell me the null values. Remove them. Fit a model. Give me the accuracy. Get me the predictions. That's how typically your machine learning journey should be. Okay, but visualizations is an added advantage. You can visualize. So in feature selection also there's something called Boruta plot, where what we will see in tree space concept. But for that, park your question till then. We'll see that later, and the visualization of how we can see like the feature can also come.
Okay. Sure, Shurit. Going on the same example where we used the first time machine learning, X was 0, 1, 2, 4, 3, 4, 5, and Y was 1, 3, 5, 7, 8, 9, 11.
Yeah.
So there was constant difference. We draw the linear regression line and we got the predicted value and which we were expecting. Then we tried to modify one data by 200 as an outlier.
Correct.
So can sklearn can tell me, okay, this is an outlier, I am ignoring that?
No. Unless and until you remove that from your data, the sklearn cannot tell you that 200 is a bad data point. How will it understand whether
then how?
Yeah.
Okay, then how will I decide whether this is an outlier? Yeah. Because that is the data, I don't know.
That's what I told, na? When I talked about distributions, when I talked about how far the data lies from the mean of the data, that sklearn is not taking care of. That your Python statistics that you have learned will take care of. Sklearn is for modeling. You have to understand that. As matplotlib was for visualization, sklearn is for modeling. Matplotlib will not do predictions for you. Similarly, sklearn will not do data cleansing for you. Data cleansing is another handled by, let's say, another package, or it is handled by Python itself. sklearn is a package for modeling. Understand that. So it is
Okay.
something that is modeling your data. Whatever you feed in, it will understand that. It will not. It is not so clever that it will also tell you what is the output, what is the outlier, what you should neglect. So you have to, give some inputs from your side as a statistician. That okay, these things are outliers. I will not fit. So XKLearn, if you feed in garbage, it will give you garbage values, like we saw in 200, right?
Okay, got it, got it.
Yeah.
Okay.
So it is not XKLearn is for modeling. It is not for cleansing your data. Okay.
Means we have to first fix the data and finally we have to give
Correct.
the SQL
Correct.
model, you can give the data.
Correct. Correct. Correct.
And so about that outlier, I know how much distance it is or how much far it is from the actual mean value
Yeah.
or standard deviation. So we have to decide how far we have to consider for outlier.
There's
And
certain there are certain thresholds normally statisticians work on. So something beyond 3 standard deviation or a 4 standard deviation will be considered outlier, or in terms of median, it is called interquartile region. So we'll come to that. Don't jump so much. We'll come to
okay.
how we can remove outlier.
Because yeah, I agree. Because I have to modify that example and I have to try to draw the linear
Yeah,
regression
no problem. So we'll
graph and everything.
deal with that. Not a problem. Okay, no issues. Vasant and Sharath, any questions from your side?
No, I'm good.
Okay, that's good. So, any feedback you have on the session? Are you comfortable with the pace? Are you comfortable with the concepts? So, any feedback you would have?
No, it's from my side. It's really very great.
Okay,
So more than expected, I am getting.
Okay, that's great. Sharath, Vasant?
Yeah, same. Good from my side. So yeah, space is good. Yeah, concepts are explained well. So good for me.
Okay, sure.
Yeah, it was good, Shobdeep. But if you take an example, like take 2 files, and if we do a like prediction, right, like you show an example like 200 entering 200 for next prediction. So that was good.
Uh-huh.
So I have a question. If you have, if I have 2 files like related, correlated data, like something related, so how do I show that prediction, example prediction of by using those files? Is there any example that I can try, or?
I didn't get the question. So you're talking about 2 files as in 2 separate data sets?
Yes, yeah.
So you have 2
Yeah,
separate data sets. Okay. Now what you're trying to do is?
No, I have to combine them and I have to show that this is the next prediction. Like you show on the 1, 3, 5, 6, 7, and next prediction is 200.
Oh, okay.
Like that.
So I mean,
Is that possible using files?
You won't say that as 2 different data sets. You should say that as a concatenation of data. I mean, you're adding some new data to the model. Okay, so that would be the correct explanation of it. And yes, that you can do. So, for example, whatever we learned in the previous classes, appending data in. So, right now, what we did is basic example of linear regression. As we go progress, we'll do a hands-on example where we have an absolute data and then we append that data and then go into the next prediction that we will do in a proper data set. Don't worry about that.
Okay.
But
sure.
Having said that, combining 2 data sets, so basically it's a function called rbind in data frame. So what it does is combines 2 data frames. For example, you have a data frame of 2 features, you have 10 values, and then you have another data frame of same 2 features and different 3 values. You just need to do an rbind of these 2 data frames. So rbind df1 comma df2, it will combine the 2 data frames and then use this as a feed to your sklearn model.
Okay.
So right now what I did it manually just to show you guys, but when you
Right.
are working on databases, you have to code it, right? You cannot input it manually. So that's where your rbind function will come. So whatever data frame you have, you import that data frame and then combine that using rbind. Yeah, you were saying.
Okay. So we will be
Okay.
looking at the database connections and everything in future classes, right?
Yeah. You'll get that.
Okay. Okay.
So one more thing. In SQL, basically, we also provide one is training set, another one is test set.
Yeah.
So can you also provide that in SQL?
So I think one thing you are not clear about, sklearn is a package for modeling. Okay. So imagine that
Correct.
it is solving an equation. Okay? It is not dealing with data. It is not having anything to do with the data. Whatever you feed in, you will get the output. You feed a training set, you'll get a training output. You feed a test set, you'll get
Okay.
the prediction. So when you're feeding, for example, in the data, in the example where we saw x and y, so for each x there was a y mapped. Okay. So when I fed that, it understood when I fit this. See the slides here. When I fit it, it is saying x comma y. Fit x comma y. So it is understanding for each x, this y is the output. This x, this y is the output. This x, this is y is the output. So this is a training set. This is a supervised training set. It
Okay.
has understood. Now when we are saying it predicting, so it is just having the x values. It doesn't have the y values. That's why it is returning the y values, right? So this is the
Correct.
test set. So it doesn't have the output. It does just gives the output, right? Predictions.
Okay.
Okay.
It means we have to write some other Python code from where it will take the output. It will verify whether it's correct or not
Yeah.
with the existing
No.
verifier test set.
No. So knowing that what will the RMSE be? I mean, it has already fitted the best model, right, on the train set
Uh,
based on the RMSE calculations. Now,
okay.
to know that RMSE, you just have to, like what we did for knowing the coefficients and intercept. Just similarly, you have to input the, RMSE parameter, and it will give you the RMSE of the model. But it has already fit the best model there.
Okay. Okay. Just one more request. Could you send this PDF file today or slides?
Slides, I will, okay, I'll check with Ashok once and see, because I need to download the videos and then upload with the, so downloading the videos, it takes a lot of time. It takes around 3.5 hours. So, and for
Yeah,
that,
no, not video, but this slides that is very helpful for us. Last
okay,
time we got, and
no problem.
that is very helpful.
Okay, no problem. I'll upload that. No problem. Okay.
Okay, thanks a lot.
Okay. Thank you so
Yeah,
much. Okay. Let's
bye.
speak tomorrow. Yeah.
Okay, bye.
Bye.
Okay. Thanks, Updeep.
Yeah.
Thanks.
Bye.
Have a good day.
Yeah. Thank
Have
you
a good
so much.
night.
Bye.